5, 6, 7 assignments before I put them in. It's much more time efficient that way for me. So that worksheet. Any questions on it? Anything you want to talk about? Cameron, you got any questions on it?
No.
No? Okay.
Yeah, I have one question.
Okay, I'm listening.
Can I do the worksheet and do this?
You can by all means do the worksheet. I would encourage you to do the worksheet. But are you going to get points for it?
Probably not.
No. Okay. But that doesn't mean you don't gain something from doing it, right?
Yeah.
All right. On homework, I only extend time if you were sick or something out of your control. Maybe you were working on your computer, all your information stored in your computer dies, right? You come to class, say, well, everything died from last week or yesterday. I make exceptions to extreme cases like that, but in general, I don't do late work. Like, I know some people will say, as long as you turn it in before the 9 weeks is over, they give you credit, right? I don't do that. It's important now, to me now, so it should be important to you now. Okay? Yeah.
Okay, the one question I have is I keep on getting an angle that's over 180 degrees. That's not possible, is it?
Not in this worksheet, and not in anything we do for a long time. So which question, what number are you on?
6.
6. How's your leg? Good? You didn't do the worksheet, did you? Gage?
I'm not the only one.
I'll show you where it's at when I give you plenty of time. Cameron, he had half his leg cut off. And, example to everybody else that's going to be absent maybe for a week, he only has one assignment to finish because he kept pace with everything.
That's true.
Okay. All right, so number 6. So measuring with TUV. So that's the whole thing here. Okay, so TUV, we're looking at that whole angle. Okay, now don't really go. I think some of these pictures are pretty accurate in regards to the total angle. So we might end up with like a total angle of like 178 or something like that. So we might see if that is what happens here. But never, and we'll talk about this in the notes today, never go off of what something looks like. Don't make assumptions about things. And did you caught your error already?
I think I did.
Okay. So what we want to do here, if that's the whole thing, now WUV is the 108, so it's that angle right there. Okay. Now TUW, okay, TUW is that angle right there, so 6x. So those are the two smaller angles that are adjacent that we need to add together. Okay. So we say 6x plus 108. Those are the two that are getting added together. And now we need a total. But we talked about TUV being that total. That's the larger angle that's developed from the addition of those two smaller ones. So there's the 15x plus 9. Now I want you to be careful of, because I've been seeing this last period. I saw a little bit on Thursday. Some people ask me questions. We get in a really bad habit, and I did this on purpose. Questions 1, 2, and 3. I believe you can take the first two expressions, add them together, and the last one is your total. Does that make sense? So you would take this one plus that one is equal to this one. Well, if you do that here, do you get the right equation?
Nope.
No. Okay. So you have to pay attention when I write worksheets. Okay. And this is one of the reasons why a lot of times the numbers aren't. Like if we go 1 to 5 and then back to 2 and then to 17 and stuff like that. The reason I do that is because I'm trying to develop the worksheet. Now, not only so you learn the math that we're talking about, but you learn some test-taking skills, and you force yourself to pay attention to detail, because those are the things that most people will mess up on like an end-of-course exam. It's not necessarily the math that's involved. It's the detail to, are they asking me for X, or are they asking me to plug it back in and find TUV, okay? Look at the first 4 questions in that assignment, they ask you for X, right? The next 4 ask you to find a measurement of an angle, okay? So, pay attention to detail, make sure we read every question, understand that every single question is independent of other questions. So, what that question is saying, don't even think about what the other ones have said. Does that make sense? And the processes I went through for the other ones. So then just go ahead and solve this. subtracting 9 from both sides, so I get what, 99. We'll subtract 6x from both sides, it's going to be 9x. That should give me 11, right?
Yep.
I don't understand how I did the equation and everything. I don't know how I got x equals 19. Like I subtracted 6x from both sides. Then
So
got
1. Oh, you transposed the 108 to 180. You just flip-flop this. So you're doing everything right. So you're good. You're fine. You're doing everything right. You just, oh, sorry. So the good thing about that, even though you missed a point, there's no disconnect in what we're trying to do here. Any others you guys want to talk about? Any other questions? Any other? Say again? So we say 8.
Oh no, I said shut up Gage. He was making fun of me.
Shut up, Gage. Quit limping. Sweet socks. Does anybody have anything else you want to talk about? Alright, no, just stretch in or?
No, well, yeah, 14 and 15.
14, 15? Alright, so 14, 15. So in the description at the top, and this is another thing, people just kind of jump straight to this stuff. You gotta read this. Okay? So J is between H and K. It says use a segment addition postulate to solve for X. Then find the length of each segment. So 14 and 15, we're going to look at something looks like this. So let's do 14. Looks like it's going to be maybe easier algebra. So do that as an example, and if we need to do the other one, we do that one too. But we got our segment. Let's say J was between H and K. So I'll put H there, put J there, put K there. Okay. Now, do I know whether J is directly between, like at the midpoint? Does it say anything about J being a midpoint? No. Okay. So we don't know where J is. It could eventually be, depending on what the values we get back, it could be a midpoint. But J could be anywhere along that segment as long as it's between H and K. Okay. Now the idea here is to say, okay, H to J, that segment there is 2x plus 5. And then J to K, that segment there is 3x minus 7. Okay? So those are your two smaller individual segments, right? Those are the two that we want to sum together. Those are the two that will, with their sum, get me from H all the way to K in regards to the distance. So we'll say 2x plus 5 plus 3x minus 7. What should those sum to? What is the total then?
18.
18, okay? K to H or H to K is a total of 18. So now we get 5x. We combine those two things. 5 and negative 7 gives me negative 2. Is 18. 5x is equal to 20. So then solving that, x is 4. Okay? So now if x is 4, come back up here. 2 times 4 is 8. Plus 5 is 13. Plug in here. 3 times 4 is 12. Minus 7 is 5. Do those two things add to give me 18?
Uh-huh.
Yeah. And now, working our way backwards to our picture, HJ is longer, right? So J should probably have maybe been located over there somewhere. Does that make sense to everybody? Okay. We initially don't understand that or know that. We just know it's between somewhere, between H and K. Once we get values, then we can reposition it if we want to maintain that scale. Does that help?
Yeah, I just realized what I did.
Okay.
I wasn't paying attention. I got 5x.
Do 15, basically those bottom ones, they were all kind of the same way. They're all same picture, they're all in the same order, kind of routine there on those four. Doable?